Okay, hello everyone. Today we're going to be doing just some factoring, going over some of the different ones. And this is a really important skill to learn. I also want to apologize if I sound real stuffed. My nose is really stuffy, but I have a pretty bad allergy. So the first one we're going to do here is the greatest common factor. And this one's fairly simple, so you just look at it, you look at the whole equation, you see the term, you're like, okay, here we have 12x cubed y squared minus x squared y plus 24xy cubed. And we're gonna look at each thing and it's like, what do they have in common, right? And so the first term, we go, okay, the 12. Let's see, we have 12, 18, 24, right? What can we pull out of those? A 6, right? So we go, okay, well, we know we can pull out a 6. So let's start with that. What else do we have here? Okay, they all have at least one x, right? So we know we can pull out an x, right? And then they all have at least one y, right? And imagine if this was like y squared, we could pull out two y's, right? But because there's only the lowest one is just one y, that's the most we can pull out of this entire equation. So then inside these brackets here, we go, okay, that the 12 becomes a 2. We took out an x and a y, so now it's x squared, and then just a y, minus, okay, that 18 becomes a 3. And then we took out an x, so that just becomes x. And then we took out a y, so there's no y there. Plus, and then 24, right? What does that become? Becomes 4. There was only one x originally, we took that out, so now it's not there. And then now this becomes y, right? And so this is our factored form using greatest common factor. This next one here, difference of squares, right? And so there's a very important formula to remember, which is a squared. Sorry, my cat just meowed. A squared b squared equals a minus b right? And so when we're looking at this equation, 49x squared minus 16y squared, we go, okay, well, this is kind of like, you just kind of, an easy way is just, once you kind of realize and you learn, your squares and your cubes and stuff like that, it becomes a lot easier to do it. And so I would say, like, if you look at it, you're like, okay, well, 49, what could that be, right? 7 squared, right? 7 times 7, right? So knowing your multiplication. You go, okay, well, like 7 times 7 is 49, right? So that becomes your A. You go 16, 4 times 4. That's 16, right? And so 7 squared is 49. 4 squared is 16, right? So if you know, like, that this formula exists, right? This one over here on the right, all you gotta kind of do when you see something similar to this, you see a negative sign, you see, okay, squared, squared, see if these, right, are these, can you come up with a figure, right? 7, 4, maybe, another, maybe it's gonna be like 2 and 3, right? So that's kind of the main thing to look at it. But just knowing that this is what it's gonna equal is super helpful. So that way, like here, right, it's just gonna be 7x and then minus 4y 1 7x plus 4. That's the other one. Right? And if you were to FOIL this out, you would end up with that. Right? Okay, and then here we have another question using the perfect square, but this time it's on a something. You can use this, right? Trinomial, but the thing is, honestly, right, like, you can use the same method. Like, okay, what two numbers multiply, like for this 25, you're like, what two numbers multiplied for this that add up to that? And you'll get the same thing. But if you, like, can recognize it right away, and you're like, oh, okay, this formula, which is a squared 2b plus b2. You know, you're gonna be in a pretty good spot in terms of just solving it. In terms of being able to just write it right away, right? Equals a plus b squared. You go, whoa, what's this? Right, so here's the a squared, b squared. What's b squared? It's 5, right? 25, 5 times 5 is 5. 2, and then this is basically 1, 5, that gives us 10. So if you can kind of figure it out, you're like, wait a second. Then you can do this formula. And just to kind of check it, right, you go, okay, 25, if we do this method, you go 5 times 5, that gives us, that adds up to 10. Those are two numbers, right? Well, x 5 plus 5 is just the same as this. Terrible, but that's the same thing. So you know this form, and in the same way, I would say this is more useful for, let's say that's what you see, right? You're given this, you're given this, and the question may be like, you know, expand this out, and you're like, whoa, and you can just write it like the first one, right? X plus 5 times x plus 5, and then use the FOIL method. But if you can see something like this right away, and you know that this is what it is equal to, then you can just be like, okay, well, x, this would be the a, so you're like, okay, a squared, and then, you know, 2a, right, like you would do that, right, so you go, okay, 10x, 25, right, so if you know this formula up here, I would say it's more beneficial, honestly, just for when you're given something like this over here, and asked to expand that, because foiling can be kind of a pain in the butt, especially if it's just part one of the things you have to do maybe for part of a problem. But you can do it in the opposite, right? If you kind of see this form in your equation, like, oh, well, that's this. But I also think just using this method can be a bit easier. And honestly, probably a bit more preferred. And on that note, right, we're going to practice another one. Basically just what we did, except, you know, it's not a perfect square. So we go, okay, minus 24. In case you weren't aware of what I was talking about when I said, oh, do the method, right? So when you have something, an equation like this is like the best case scenario that you can find. Well, maybe not the best case. Actually, no, it is. It's the best case if you can find out, you know, the factor at using just this method and not the quadratic formula. You would go, okay, what number with the sign do we need to get this, right? What two numbers multiply to give us negative 24 in this case? And then with the sign, but add the negative 5. Right? And some people may kind of have like what methods they like to do to find the number, because sometimes it can be kind of tricky, and you know, it's not something that's just like, oh, it's just the number itself divided by 2. So, you know, it's not, oh, it's 2 and 12, right? Or something like that. Or like that's sometimes not the case. And so I'll usually do that, or just find the different things and go down the list. Ones that are not that are obviously 2, not going to be reality. So I'm not going to be like, oh, is 1 times negative 24 maybe the answer? It's obviously not going to be, right? Because in no world is it even close to coming to negative 5. Now, what I will say is, when you have, let's say that this was positive 24 and a negative 5, it's going to be two negative numbers, because you need two negative numbers to give you positive when doing multiplication. And there's no way that it can be two positive numbers and you end up with a negative number, right? That two positive numbers that are adding together give you a negative number. Now, in this scenario, right, where we have a negative multiplication, right, and multiple sum, a sum of multiplication that is negative, it's going to be one positive, one negative. So that's kind of a good thing that's going to kind of help us and be like, okay, well, we know that's going to be the scenario. So we'll go, what's maybe potentially more realistic? Um, you could go, okay, what about 3, right? 3 and 8. 3 times 8, let's say -3. Okay. Well, that just gives us 5. What if we flip the signs? What if we say -8 times 3? That gives us -5. All right. You could have done, maybe you were thinking, oh, like 4 and 6, right? But, something like 1 and 2, when they're so far out, it's not really worth even testing. But that's kind of thing, right? So we know 1's going to be negative. And even if you get the first one technically like wrong, right? That's giving me a +5. Just flip the signs. I have a -5. And so the way it would look then is, okay, x -8, x plus, and that's our factored version of the original equation. Okay, so now we're doing kind of a similar problem. However, something's a bit different about this one, right? Our first term, we have a number here, right? It's 6, not basically 1, right? And the before our coefficient was 1. It's just because it's 1, we don't write it. But let's say, if it's 2, 3, 4, in this instance, it's 6. How do we go about doing that? Well, if we did the exact same thing that we just did, right, we would get a completely wrong answer. Because there's an additional steps that we have to take. So the first one being is we would take this coefficient here, so 6, and multiply it by this number, right, the AC method. That would give us, because we had to include the term, -60. And we're going to do the same thing that we did to find the two numbers, right? But there's going to be something a little different. So, see these two numbers, you're like, oh, these are a little bit more tricky, right? Kind of a similar thing, right? Obviously, we did 1 and 60, right? Or 2 and 30. You're like, well, that gives us 60. Yeah, but in no world is that going to give us 11. So that's why I kind of say it's like, how can you make the AC method better? Just try to be, okay, clearly those two numbers are not worth testing and wasting our time on. And so when you're in an exam, let's say, right, obviously you're not going to really waste that much more time, but it is kind of a waste of time to even do those. And so, I mean, sometimes it's not if you want to be super thorough, but obviously, 1 in 30, or sorry, 2 in 30 or 1 in 60, in no world, a -60 and 1, or what, you're not going to get an 11 when you do addition. So that's important to kind of think about. But let's go down. Let's say, okay, what about 10 and 6? Okay, well, 10 multiplied -6, that gives us 4. That does give us -60, but when you add them, that gives us 4. What about 12? 12 and -5, that gives us 60, but that only gives us 7, right? Okay, 15. 15 and 4 gives us 6, -60, and that does give us 11. So these are your two numbers, right? 15 and -4. But instead of before, where we would just write like, oh, x plus 15, x minus 4, call it a day, right? We're going to split this up with our two numbers, right? And then let's rewrite our equation. 2 plus, I'll do 4 on this side. It doesn't really matter. Sorry. This is 2 plus 15. There's a situation I want to show that I think is pretty useful. Oh, and these have x's, by the way. -10. And then we just factor by grouping, so we'll write it here. Write one here. Okay, the first one, what can we pull out, right? Well, we see there's x's. That's a common thing that we know we're going to pull out, so we're going to for sure pull out an x. What number can we pull out though, 2? We can pull out a 3, right? We couldn't do 2, but we can do a 3. So 3x comes out, and what's left inside? 2x for here, and then for here, right? Just a 5, because we also took out an x. And then here, it's kind of hard to see, but this is a -4x minus 10. And so you go, well, there's no x in common, but there is a 2. However, we don't pull out a positive 2 because there is no positive 2, right? We pull out a negative 2. And then inside, right, you're effectively just, okay, to find what's inside, you go, okay, negative 2 divided by negative 4x. It gives us positive 2x. Negative 2 divided by, or 10, I guess. Negative 10 divided by negative 2, right? Two negative numbers multiplying, or two negative numbers dividing, you're going to get a positive. Then that becomes positive 5, right? So then we rewrite it like this. The numbers on the outside is one equation. The numbers on the outside are going to be one thing. We're going to put those two together. And then on the inside, and then on the other one is just going to be the 2x plus 5. Right? And that's our answer. Okay, and then we just basically did a little bit of grouping. And so if you were kind of confused, like, huh? Right? Grouping. Basically what we just did. And so you would take it and you kind of just split it down the middle. Right? If you're given, and it's 4 like this, it's pretty simple. And so you go, okay, well, first term, what can we pull out? Can't pull out any numbers because there's only an x2. But there is an x3 and an x2 here. You can pull out at least an x2, right? X squared. The other side, no x that we can pull out, but we can pull out a 3, right? 3, and then we're just left with an x, 2, so then an r. Factored version, this is a positive 3. That right here. And so I hope you learn a bit more about factoring. Hopefully, if you had a lecture recently over factoring and you're kind of like, man, I have no idea. Hopefully this video kind of helped out a bit. Gave you a couple more extra problems to practice on your own and see them be solved. Kind of make more sense about it because, factoring is a pretty important skill, I guess, like foundational skill, especially if you're going to do any higher level math than just algebra. So I hope you have a great day. I hope you learned something, and I hope you do well.